Assalamu alaikum everyone. I hope you are all fine. Today we will continue chapter 1 classification of matter, talking about solid, liquid and gas, and then moving to mixture and pure substance. Activity 6, measuring the shape and volume of a gas. The materials used here are stand, iodine, rounded bottom flask, Bunsen burner, tripod, filter paper and wire gauze. Procedure. Introduce a few iodine crystals in a round bottom flask and cover its mouth with a filter paper. Here we have the round bottom flask. We put iodine crystals, then we cover the opening with a filter paper. Heat the bottom of the flask for a few seconds. We light the Bunsen burner and we gently heat the flask containing the iodine. Then adjust another round bottom flask in an upside down position. Here is the second round bottom flask in an upside down position, just above the previous one as shown in figure 5a. Here are the two round bottom flasks. Remove carefully the filter paper, keeping the opening of the two flasks in contact as shown in figure 5b. Here are the two flasks, their openings are in contact, and we remove the filter paper. When we heat the iodine, what will happen? The temperature will increase. So iodine will begin to sublimate, change from solid directly into gas. The iodine gas will travel through the opening and fill the second flask. As you can see here, this purple color is due to the presence of iodine gas. So, based on this experiment, we conclude that gas has indefinite shape and it takes the shape of the container and it fills all the available space, as you can see here. It fills the round bottom flask and its shape is the same as the shape of the container. Also its volume is the same as the volume of the container. So gas has indefinite shape and indefinite volume. Explore. What happened to the iodine crystals upon heating in step 2? What is its color? Here, upon heating, iodine crystals sublimate. Sublimate means change from the solid directly to gas state. So, iodine crystals sublimate. What is its color? Its color is purple. What happened to the gas after removing the filter paper? It diffuses into the other round bottom flask. Conclude. What shape and volume does a gas have? The shape and the volume of a gas take that of a container. So, gas has indefinite shape and indefinite volume. Activity 7. Classifying distilled water as a pure substance. The materials used here: distillation apparatus. This is the distillation apparatus. 300 milliliter beakers. Wooden clamp. This is the wooden clamp. Heating mantle. This is the heating mantle. Thermometer. This one is the thermometer. And distilled water. Procedure. Put into 3 beakers samples of distilled water obtained from various sources. So, we fill 3 beakers with distilled water from different sources. Examine some characteristics of these samples, like the color. What about their color? the color of the distilled water is colorless, and also distilled water is odorless. What about the appearance? Distilled water is clear, right? So in the three beakers the appearance is the same, so in the three beakers they appear clear, so appearance is clear. Carry out an experiment to vaporize sample of distilled water from each beaker. If we want to boil these samples, we will obtain the same boiling point. Carry out another experiment to determine the density of different samples taken from the three beakers. If we measure the density of water in the three samples, what do we obtain? We obtain the same value. So pure substance has constant density. Explore. Can you detect any difference in characteristics between all the samples in step 2? We said that the color in the three samples is the same, or all are colorless, odorless, and the appearance is clear. So the answer is no. At what temperature will all samples of distilled water boil? As you all know, water boils at 100 degrees Celsius. This is distilled water, it's a pure substance, so it has a constant boiling point, which is 100 degrees Celsius. Compare the density of the three samples. The three samples have the same density because the three samples contain distilled water. The density of the distilled water is constant. What do you conclude? Are all physical properties of different samples of distilled water the same? Yes. So the physical properties of the distilled water, which is a pure substance, are the same. Activity 8. Complete vaporization of seawater. The materials used here: test tubes, dry and clean, Bunsen burner, wooden clamp, and seawater. What's the meaning of vaporization? It is the process in which liquid changes into gas. So, in this experiment, we have seawater. What's seawater? Seawater, it is salty water, so it is salt dissolved in water. It's a solution of salt dissolved in water. This is the seawater. Fill 1/3 of a test tube with seawater. One third of the test tube with seawater. Then heat gently the test tube with its content till the liquid disappears completely. So the liquid will vaporize completely. So when we heat the seawater, water vaporizes and the salt remains in the test tube or at the internal wall of the test tube. Explore. What do you observe on the internal walls of the tube after complete vaporization? A solid residue due to the presence of salt. Conclude. Is seawater a pure substance or a mixture? We said that seawater is made up of salt dissolved in water. So it's made up of more than one pure substance, right? So it's not a pure substance, it's a mixture. So seawater is a mixture. Can we say that water is made of more than one kind of material? Yes, of course. It's made up of more than one kind of material. It's made up of salt and water, so the answer is yes. Now let's move to activity 9, the vaporization of salt water and pure water. The materials used here: 2 flasks, dry and clean, Bunsen burner, thermometer, distilled water and seawater. So here we have distilled water, which is a pure substance, and we have seawater, which is a mixture. It's a mixture made up of water and salt, right? Procedure: fill partially 2 flasks with distilled water and salt water respectively. Here we put distilled water and here we put salty water. Heat the 2 liquids in the flasks till boiling. We heat them both. Record the temperature at which each liquid starts and continues boiling. Look at the temperature here. The temperature is 100. This is the boiling point. What about the temperature here? This is the 100. The temperature is above 100. So the boiling point of a distilled water is 100, while salty water it is above 100. So they have different boiling points. What is the starting boiling point of distilled water? How does it continue? The boiling point of distilled water is 100 degrees Celsius and it does not change, it is constant. What is the starting boiling point of salty water? How does it continue? This is the salty water. The temperature is above 100 and this temperature continues increasing. So the boiling point is not constant here. Conclude. Is the boiling point of a pure substance mixture? Yes, distilled water is a pure substance and it has a constant boiling point. So pure substance has a constant boiling point. Is the boiling point of a mixture variable? Yes. Conclusion. Mixture and pure substance. In activity 7, distilled water is examined with respect to some characteristics such as color and odor, and to some physical constants as boiling point and density. From this experiment, we find out that distilled water has the same characteristics and physical constants such as the boiling point. It has a constant boiling point which is 100 degrees Celsius. So distilled water is a pure substance that has the same characteristics throughout. Distilled water is odorless, colorless, and it appears clear. So these characteristics are the same, and it is made of one kind of material which does not separate into other substances by physical means. So the pure substance is made up of one kind of material and it has specific and constant characteristics, and also it has the constant physical properties such as the density and the boiling point, the melting point. In activity 8, seawater is completely vaporized where a solid residue is left in the tube to show that seawater is not a pure substance since it is made up of more than one kind of material and hence it is called mixture. So seawater is a mixture. It's made up of more than one kind of material. A mixture is made up of two or more than one kind of material. In activity 9, the vaporization of distilled water and salty water is carried out. We find out that the boiling point of a pure water is 100 and does not change with time, while salty water starts boiling at a temperature above 100 degrees Celsius and increases with time. So the boiling point here is not constant. This is a mixture and its boiling point is not constant. The boiling point of a pure substance is constant, while the boiling point of a mixture is variable. So, pure substance is made up of one kind of material. It has a constant physical properties and it has the same characteristics, while a mixture is made up of two or more materials. This mixture has different characteristics that are not constant and they change. Now let's solve exercise 6, page 22 in your book. Classify the following as a pure substance or a mixture. As we explained before, pure substance is made up of one type of material or one kind of material, while a mixture is made up of two or more kinds of materials. Air, is it a pure substance or a mixture? Air is made up of many kinds of gases such as oxygen, carbon dioxide, nitrogen and other gases. So air is a mixture, it's not a pure substance. Urine is a mixture. It's made up of water and many different substances such as urea and salts, in addition to some toxins. So it is a mixture. It's made up of more than one kind of material. What about snow? Snow is made up of tiny icy crystals and air, so it is a mixture. Part D, a piece of meat. Meat is made up of different components, including water and the protein. So it's made up of water and the protein mainly. So it's a mixture, it's not a pure substance. E, we have alcohol 95. 95 means 95 plus 5% water. So it's a mixture of alcohol and water. So alcohol is also a mixture. Part F, what about toothpaste? Is it a pure or a mixture? Toothpaste is also considered as a mixture because it is made up of many ingredients such as fluoride, flavoring agents, many other materials. So it's made up of more than one kind of material. So it's a mixture. What about ice cream? Ice cream is also a mixture. It's made up of cream, sugar, flavors, and many other ingredients. So it's also a mixture. Iron powder, it's a pure iron, so it's a pure substance. And also sulfur is considered as a pure substance because it is only sulfur. It's made up of only one kind of material, which is sulfur, so it's a pure substance. Please, I want you to copy this table on your copybook. Write the exercise number 6 and don't forget to write the page number. Thank you for watching. See you soon, inshallah.